John Gulliver, Professor of Civil Engineering at the University of Minnesota. Welcome to Access Minnesota.
Thank you.
John, you work at the St. Anthony Falls Lab. Give us a little bit of a background on the lab. What are the projects currently underway?
Okay, the lab has a long history, about 70 years of history. It was built in the Depression with WPA money. And the projects currently underway are actually highly varied, so people do work on different things. There's river work going on, mostly rivers and lakes, some underground turbidity currents, some offshore oil type exploration research. So there's a wide variety of water resources research. We're basically a water laboratory.
Minneapolis started at the falls. So this is the falls here are the center of Minneapolis. The reason it started here is because of the use of the water power to first for sawmills, after the trees were all cut down, then flour mills because people were growing flour, and finally hydroelectric power. The city actually started right here at the falls. It's about early 1800, early 19th century. Well, the laboratory has an outdoor stream lab here, which is actually taking what we do inside the laboratory and putting it outside. And there are some differences between what you can do inside the laboratory and what you can do outside. For example, inside the laboratory, you can do lots of things with flow, but it's difficult to grow plants. When the Guthrie came up, we looked across the river and we saw this big picture of Tyrone Guthrie looking at us. And we said, well, we have to give him something to look at. And so we built these, placed these big banners out here so that the people and Tyrone Guthrie would know that we are not some energy center or some hydro plant or some place where secret research is going on. We are part of the University of Minnesota, doing research for the University of Minnesota, and it provides a nice visual. I'm working on hydraulic structures like these falls here. These falls are entrain a lot of air. The air helps re-aerate the river. It helps add oxygen to the river. The question is, how much air do you need to add oxygen to the river, and how much oxygen is needed? So that's basically, the falls help the water quality of the Mississippi River.
Now here at St. Anthony Falls in Minneapolis, apparently it's an ideal location for the laboratory. Why is that so?
The reason is because the falls provide the head needed to get the water to the laboratory. So the laboratory is right underneath the falls, or kind of right next to the falls. We open up the gates upstream and we can run up to 300 cubic feet per second through the laboratory, which is about the same that you would have in the Vermilion River or the Rum River.
Access Minnesota will return after these messages. You're watching Access Minnesota. Here's Jim Dubois.
Now, more of our conversation with U of M professor John Gulliver.
If you walk through the streets of Minneapolis and look at the storm sewers, every now and then you'll say, storm sewer runs off to Minnehaha Creek or to the Mississippi River. Tell us a little bit about what your studies are finding, and how big of a problem is urban pollution from what runs into the storm sewers and eventually into our lakes, rivers, and streams?
Yeah, urban pollution, it has been the coming problem for a long time. You know, we cleaned up the point sources, that would be the sewage treatment plants. We did a pretty good job of that. And then we found that our rivers and our lakes were still polluted. Not as much as they used to be, but they're still polluted. And the reason is because there's a lot of things on the streets, and storm sewers basically drain water off the streets. And before we had streets, we had pastures, we had woods, and the water would not drain off that rapidly. It would soak into the ground. Now it hits the street, it drains right off, goes into the storm sewer. There's lots of pollutants on the street. Pollutants from cars, pollutants from dirt that's been left on the street by the cars, oil from the cars and the trucks and things like that. So that all ends up in the receiving water bodies, which is our rivers and our lakes.
How big of a problem are chemicals from, say, people's lawns, fertilizer, for example? Is that an issue of the runoff from that going into the storm sewer system?
Fertilizer is an issue, especially in terms of nitrogen and phosphorus. If you have a lake downstream, the lake is controlled by phosphorus. That means the productivity of the lake is controlled by phosphorus. Productivity is not a good thing for a lake because it becomes a swamp when it gets too productive. So we don't want our lakes to become swamps. So we want to control the phosphorus that goes into the lake, and you have runoff from fertilizer put on the lawns, and that will run off into the lakes.
Now, you talk about a body of water becoming more productive. This summer in Minneapolis, you see these large machines on the lakes, Lake Calhoun, Cedar Lake. And from what I understand, that's basically dealing with the milfoil problem. Is this an issue of runoff that has caused these lakes to become overproductive?
Yeah, there are some species that do better when you have an overproductive lake, when you have a lot of phosphorus in them, a lot of nutrients. And those species tend to be species that we are not excited about having in our lake. That would be species of plants and species of fish.
Some of the other research you're doing has to do with air bubbles. Tell us more about that.
I'm interested in how air transfers compounds from the water into the water. So I'm interested in how much mass transfer you have across the bubble water interface. And air bubbles are an interesting phenomenon. Air bubbles occur at all hydraulic structures. That would be like dams, spillways, things like that. Like you have bubbles in the St. Anthony Falls, you have bubbles downstream at the Ford Dam. They entrain a lot of bubbles, they put the bubbles into the water. From some points of view, that is a good thing, and from some points of view, that's a bad thing for the water quality. So I'm interested in the impact of bubbles upon water quality.
Now, prior to the BP spill, actually a good decade prior to that spill, you came up with a plan to deal with a potential oil spill on the Mississippi River. Tell us more about that.
Well, actually we started working on the Nemadji River oil spill. That was an interesting oil spill. There was a train, a whole bunch of train cars with oil in them crossing the river, some sort of oil. Actually, they call it product. We weren't really sure what was in it. And that one of these train cars fell directly across the Nemadji River. And so it just broke in half and just spilled everything into the Nemadji River. So that was about 30,000 gallons of oil in the river all at once. The BP spill is spilling about 30,000 a day. So that's like one day's spill of the BP River instantaneously in the Nemadji River. And so that's where we started working on it, because we were contacted by people who wanted to determine the environmental impacts of this spill on the aquatic biota. That would be the plants and animals, the fish in the river, and the lake downstream. It empties into Lake Superior. And they didn't have a model to do it, so that's why we developed the model.
Tell us a little bit of the specifics of the model. What would happen, say, for example, if there were an oil spill in the Mississippi? How would that be contained?
Containment is difficult. It always is, even on the Mississippi, because you have a velocity of flow moving past. You try to put an oil boom or something out there, and the velocity will just take the oil and put it right underneath the boom. And so containment is always a difficult issue. The booms they currently use on the Gulf of Mexico are not necessarily containment booms. They are adsorption booms. So they basically absorb the oil, and then they get full of oil, and then you have to replace them. So you frequently have to replace them. And that might work on the Mississippi. I'm not sure about that.
Now, in terms of containment, we'll assume that it might be possible to stop the spill from getting larger, but how would you actually go about cleaning up the spill? What is that process like?
If you're talking about an oil spill, you have oil does not really like water. It likes the sediments, and so it'll get up in the sediments. So then you're caught, just like the beaches, you're caught trying to clean all the sediments on the bottom of the river or the sediments on the bottom of the lake. It's very expensive and very difficult to do. So the compounds in oil will go into the water and then go into the sediments, and then you've got a big cleanup problem. And how do you get it off? Well, then you get all the sediment, you dig up the sediments, you dredge the sediments, you treat the sediments, you burn the sediments. It's a difficult problem. So the question is, how much of an impact do you have? Because you will have an impact.
How is the state of Minnesota utilizing your plan if there is an oil spill on the Mississippi? Do you coordinate with the Minnesota Pollution Control Agency? How would that work?
Well, the Minnesota Pollution Control Agency has a plan. It is not for the environment. Our model, the model we developed, is for the environment. The plan the Minnesota Pollution Control Agency has is for people. When do they have to shut down the drinking water facilities? How long do they have to shut them down, which is an important factor. And that's what their plan is for. We are more kind of, our model more would come in afterwards to figure out what the environmental impact was, or to plan for the assessment of the environmental impact.
Based upon your research here at the lab, what are the biggest threats to Minnesota's waterways in terms of pollutants?
Heavy metals are a big threat to the waterways. The sins of the past are contained in the sediments of our rivers. And so if you put a heavy metal in the river, it'll go straight to the sediments. If you spill oil in the river, it'll go straight to the sediments after a certain length of time, after a certain transport. And so the sediments will contain, can be highly toxic. And then once they're highly toxic, it's difficult to clean them.
What should we be doing to minimize these threats?
Source reduction. We should reduce the source. So that would be in stormwater, you would reduce the source of the metals. So that means you catch the metals where they fall. So they fall in the streets, you want to catch them up near the streets. You don't want them to go into the storm sewers. If you're talking about oil, the same thing. You would catch them close to where they fall. And so source reduction is really the answer.
And what can, say, a homeowner do? Can they watch what kind of chemicals they put on their yard? What can they do to minimize runoff into the storm sewer system?
Well, the state of Minnesota, in terms of runoff, the state of Minnesota, no, actually, I'm sorry. It's the Minneapolis, St. Paul area has passed a law saying that you cannot use phosphorus in your fertilizer. And that makes sense because we actually have phosphorus in our drinking water for the city of Minneapolis. And so we are watering our lawn with phosphorus-laden water. And so it doesn't make any sense to put phosphorus onto our lawn. And so that will help the phosphorus pollution quite a bit. The other thing that they can do is not put oil down in the storm sewer, because that goes straight to a river. So if you change your oil, the last thing you want to do is put that down into the storm sewer. If you have some metals that you don't want to put them in the storm sewer, you want to keep them out of the storm sewer. The other thing a family can do is build a rain garden to trap what comes down the street. So you have pollutants coming down the street, and you build a curb cut, and the rain garden will trap those pollutants, infiltrate the water, and filter the water. It's actually a very good thing.
Do you have any resources online here at the lab where people can go to get more information about your research and about what people can do to mitigate damage to water?
Yes, we do have. We have an online manual, actually, for stormwater anyway, that they can have access to.
John Gulliver, Professor of Civil Engineering at the University of Minnesota, thanks so much for joining us on Access Minnesota.
You're welcome.
That's all for this month's edition of Access Minnesota. Thanks for watching.
Access Minnesota. Issues that matter to you. Join us again next week as we bring you the newsmakers and stories that shape our everyday lives. Access Minnesota is produced by the Minnesota Broadcasters Association in cooperation with the University of Minnesota's College of Liberal Arts.